All right, hey, Mr. Fortin here. I haven't made one of these asynchronous problem set help on homework videos in a while, so hopefully it provides you some relief of knowing that you'll have a teacher walking you through at least some of these examples here. So you got to do the odd numbers. I know those answers in the back of the book, right? I want you to be able to check your answers here, but I also want you to be able to do some of these complex problems because once we get to this, right, once you finally start seeing some shapes, right, you're just doing geometric mean stuff before that. Before you get to all these shapes here in these diagrams here, you're already at B-level problems. So already starting it out here, your book thinks these problems are a little challenging here. Okay, so in this one here, a little challenging than A-level problems, we're just finding geometric mean. We're just going to work it out together and see if we can get really digested the stuff that we did yesterday in class, the classwork, and also the video lesson and exit ticket. It says here each diagram shows a right triangle with the altitude drawn to the hypotenuse. That's good, right? We have a theorem, similar triangle, and then a yes, similar triangle here. Find the values x, y, and z. So obviously we can figure this stuff out through definition of similarity. We can set up proportions, but why spend the time doing that? Because we had corollaries, right? Corollaries that told us that some of these shapes are the geometric mean. The lengths are the geometric mean of the lengths of other parts of the shape. So you want to flex that you know those corollaries and get this done really quickly, right? You're not so bad. All right, first thing I see here, right? So this is why this is a tattoo. Altitude. Geometric mean of the segments of the hypotenuse that got created by the altitude and the original hypotenuse. There we go. Not too bad. Not too bad. Okay, check it out here, geometric mean. So you can think about it in terms of some similarity, but I'm not going to, right? Because we have the corollary, right? We talked through the logic of the corollary yesterday. We're going to accept that corollary as the theorem. So x here, I got that in the mean position. My extremes, 4, 25. Okay, the segments of the hypotenuse form the extremes in my statement here that I'm trying to find sort of the average of 4 and 25 in sort of this proportional way here. Okay, to solve that, what do? We cross multiply. Okay, means extremes property, right? That's what that's called. This is really easy. Check it out here. X times x is x squared. And boom, what's 4 times 25? Well, that's a nice, it's giddy. That's a perfect square because that's 100, okay? To solve this, when your variable is being squared here, you can undo the squaring of the variable by simply taking the square root of both sides here. This here, that's technically taking this to the 1/2 power. Remember that? Fractional exponents from last year? Okay, x squared, take the square root. That's going to cancel out this. I just got to square root that side. Square root of 100. What's the number that when multiplied to itself becomes 100? That's right, 10. So x equals 10 right here. There's my first answer. So I got that. That's going to maybe help me complete the puzzle for the other parts. Or no, it's not, actually. I know what you're thinking, too. I'm just going to use Pythagorean Theorem here. No, don't use Pythagorean Theorem. We don't have proven the Pythagorean Theorem yet. So please do not do the Pythagorean Theorem on this homework. Don't do it. Use the geometric mean corollaries here. So we have y right here, and y is a geometric mean. Let me get rid of this here. I'm gonna get rid of this because the blue is what I'm using for my geometric means. So remember the original triangle, the legs of the triangle, each leg of the triangle is the geometric mean of something. This leg here is the geometric mean, and let's get rid of this here of the segment of the hypotenuse. Here's where reading the words in geometry is kind of tough because you got to see it visualized a few times. This leg of the large right triangle is the geometric mean of the segment of the hypotenuse that is adjacent to that side. I didn't really fully define that, but that's what that's talking about. It's the part that's cut off from the altitude over to that side, to its endpoint. That's the segment of the hypotenuse that's adjacent to that side, and the hypotenuse itself. So let me identify this here, okay? So this is just one of them crazy laws of math, okay? The whole hypotenuse, we haven't figured that out yet, but by the segment addition postulate, 4 plus 25 is 29. So we have that there. This here, this length y, because of this is proven for us here, it's sort of the geometric average of 4 and 29, sort of the proportional average, the go-between, right? The geometric mean. So 4 and 29, okay? Not 25, because if it's 4 and 25, right, it'd be this altitude. This is a little bit longer. Look, it's a little bit longer than this guy here. So 4 and 29, that's going to have a higher geometric mean than 4 and 25. So let's go ahead and do that one here. We're going to do y is the geometric mean of 4 and 29, and it's just like the other problems you did earlier here. Y squared equals, well, 29, this is not going to be a perfect square here, so this is going to be 16 more, so it'll be 116. If you want to simplify your let's put the radical symbol in there. So if you want to simplify your radicals, This is another way you can think of 116. Is that divisible by 4? Yes, it is. Well, obviously, it's 29 here. 29 is not a prime. 29 is a prime number, huh? Yeah, 29 is a prime number. We have the 4 there, so you don't even need to go to the 116 here. You could leave it like this. Square root of 4 times by 29, and then we can just take, you're allowed to take the square root of just this number, right? Just that here. And square root of 4 is 2. So technically, the easiest way I can write my answer here is 2 root 29. There we go. There's my second answer, Z. Z is my last answer. Don't do Pythagorean Theorem. Don't do it. No, don't do it. We're going to get rid of this here. We're going to get rid of the Y. And here, we're going to, this is the geometric mean between this, right? This is it here. 1, 2, 3. 3 geometric means. The last one you need to be concerned about is the other leg. Geometric mean between the hypotenuse and the segment of the hypotenuse that is that it's adjacent to. So right here, so 25 and 29, and it kind of makes sense, right? Does my answer gonna make sense? Yeah, it's gonna be a geometric mean between 25 and 29. That's gonna be higher than 2 root 29. It's gonna be higher than 10. If you put a decimal there, that's fine too. If you did this, if you don't want to simplify your radicals, we're going to be doing that on Wednesday. This little thing that I'm doing right here, simplifying radical expressions, that'll be Wednesday's class. So hopefully I've at least isolated this here. This is the segment adjacent of the hypotenuse, adjacent to this leg with length Z. And this is the hypotenuse itself. So let's go ahead and do this. This is Z here. This is Z here. And this is 25. And this is 29. And I might just do this here. This is going to be Z squared equals 25 times by 29. And I might actually just put that in the square root symbol. I might actually multiply that out. Why? 25 is a perfect square. Why multiply that out and figure out how I could simplify the radical if I could just take the square root of 25, which is what? Which is 5. So Z is going to equal 5 times root 29. Okay? So check it out here. This is root 29, 2 times it. This is like 5 over 2 times larger. Right here, because this is 5 root 29. It's not just 2 root 29. So kind of think about this as kind of like the coefficients of radical expressions. Okay, there's one. Here's a second one. I get a second example. Whoa, we see fractions. Why? For the love of God, why fractions? All right, anyways, let's see if we can do this nice and quick. I gotta pick up my daughter at daycare. All right, we got X here. That's the geo mean between each segment of the hypotenuse that got created between the altitude and the endpoints here of the hypotenuse. There we go. That's the easy one, right? That's the one you want to start with here. Remember, if you're exit taking, some of these ones get a little bit harder. So we're going to have this here. X is the geometric mean of 1/6. Ooh, wait, a fraction in a fraction? Wow. This is going to be tough. 1/3 right there. What? Like, we got a fraction in the denominator? We got a fraction in the numerator? That's wild. Hey, this is a little bit hard for people here to know. So maybe just quick aside on this here. This guy here, X over 1/3, you can think of that kind of as X divided. Remember, this fraction mark means divide. X divided by 1/3. Okay, you can think of it as that. And then here, if you're dividing by a fraction, X is getting divided by 1/3. What is dividing by a fraction do? What do you have to do? Well, you have to change that to multiplication and flip the fraction. So you get 3x right here, right? 3x. So this here simplifies to 3x. One thing that I'd like to say about this here is, well, where did the 3 come from? The 3 is the denominator of the denominator. Where is it going to end up? It's going to end up in the numerator. Follow my logic there. It's totally right? I've done this a little bit here. So this right side here actually simplifies to 3x. This is a little bit different over here, okay? This is a little bit different on this side here. 1/6 over x, we can think of that as, right, 1/6 being divided by x, right? X over 1, right? X over 1 being divided is that, okay? What's that? That's the same thing as multiplication, you say. Well, that equals 1/6 times by 1 over x. Well, same thing as multiplication. We just flip the fraction, flip the second one. That equals 1 over x. So this here, look, this 6 here is in the denominator, the numerator. Where should it really go? It should go to the denominator, because check it out here. 1/6 being divided by x, that's the same as 1/6 times by 1 over x, right? Flip. Remember, you should have done this before in the past, right? Dividing by fractions before is how I'm justifying it for you. So this is going to be 1 over 6x. Okay, that's what this is going to simplify to. Where did the 6 come? Well, the denominator of a numerator goes to the denominator if you're simplifying fractions. So this class isn't about simplifying fractions, but you practice that. And I just explained it a bit for you here, and ask questions. Be curious, try to get there, right? Try to get there. So I got this. right? That's what I got so far. Okay, what do you do now? I would, honestly, I change this back to a fraction and I cross multiply. That's what I would do. So I got this here. 1 times 1 is 1. And 3x times 6x, well, this is going to be hard. People are going to have trouble with this one, is going to be 18x squared. Oh, man, this is a tough problem for you guys. I might see some question marks here when we review this on Wednesday. What do you do to both sides? Well, I want to solve for 1x. I probably should get x squared first rather than 18x is here. So simplify away from the variable here. What happens first, the variable gets squared. Second, we get multiplied by 18. So I say simplify away from the variable first, and then you have 1 over 18. Look at that here. Oh, man, this is gnarly. This is a gnarly problem here. Then I get x squared equals, and I got to go too, 1 over 18. And that's what equals x squared. Man, this is a lot to kind of simplify here. I know that 1 over 18 equals, so I want to take the square root of both sides. Let's maybe do that. X equals the square root of 1 over 18. That's the same thing as x equals the square root of, 1 over 2 times by 1 over 9. Okay, 1 over 9. 1 over 9 is something that I could take out here. That's going to be 1/3 times the square root of 1/2. Equals x, and then hey, maybe we'll just leave it like that here because we have another problem with this one. We gotta get rid of that. You can't take a square root of a denominator. That'll be coming up on Wednesday's class. Man, this problem might be a little bit too hard for you guys right now. Anyways, wow, this is a tough one. Here, this one here. What are you gonna do for this one to get y? Well, y is the geometric mean of what? 1/6. Okay, geometric mean of 1/6. And 1/6 plus 1 over 3, so that would be 2/6. So that would be 3/6, which would be a half. Okay, a half. There you go. There's your equation, right? Y squared equals 1 over. Right. So actually, I didn't even need to simplify my fractions. I could have just cross multiplied here. That might have been easier, right? Y squared, and then that's 1 over 12. Okay, 1 over 12. And if you just want to leave your answer like this as y equals the square root of 1 over 12, fine, we're done. I'll teach you guys how to simplify your it's called rationalizing your denominator. That's going to come up on Wednesday's class. You can't actually take a square root of a denominator. It's just like something that's not allowed. So we have to actually change the way we write this. That's not going to be totally done here. All right, finally, last one, z. Oh, man, I really got to get out of here. Z, and I'm going to take 1/3. It's the geometric mean between 1/3, not 1/6. And we know that the hypotenuse is 1/2. So that's z over 1/2. Cross multiply. I get 1 over 6. Yeah, this is 1/12 here. Good. Equals z squared. And finally, take the square root of both sides. And I get, well, the square root of 6 equals z. And we'll leave it like that for now, okay? Thank you guys for watching. I'm sure I would have gotten plenty of questions about that one. I probably still get questions about them. Hopefully this makes your life a little bit easier and brightens your day on a Tuesday, seeing a Mr. Fordham video. I will see you guys later. Have a good Tuesday. Instagram's problem set. Best of luck. Email me if you have any questions. Bye.